Welcome to Machine Learning. In the classroom, I first hand out the syllabus to students. For people who are watching the video online, you can find the link to syllabus below the video. This class is mainly for middle and high school students. Ideally, the student is an 8th grader or above who already knows algebra, geometry, and Python programming, because having such knowledge will make it easier to grasp concepts and techniques to be taught in the class. What about you are not yet 8th grader or you haven't learned algebra, geometry, or Python? Well, since you are watching this video, I would assume you are interested in the subject and you are self-motivated. If there's a will, there's always a way. You can catch up relevant algebra, geometry, or Python programming knowledge on your own, such as by exploring the internet resources. For adults who don't have a quantitative background but would like to learn and apply machine learning at work, you may also find this course is useful. This course is a year long for about 38 school weeks. For the first two-thirds of the time, we'll learn concepts and techniques related to machine learning. In the last one-third of time, students will apply classroom learnings to a project and solve a real-world problem. For student, the project could be an independent study or science fair idea. We'll have more discussions about project as time goes. To learn anything, a person needs to have commitment. In addition to attending weekly lectures, I'll expect a student to spend at least 2 hours a week to practice on his or her own. This course is coined with the name of Machine Learning. First question for you. What does I in the name stand for? Obviously, this is an introduction course to machine learning. If I teach the course well, you may also find it interesting because you enjoy the interesting topics covered in the course. It is intuitive. You get the intuitions behind the concepts and techniques on machine learning. So it is intuitive and easier for you to learn. After a long time, even if you don't remember the nitty-gritty details or formulas, you still have the big picture of ideas in your mind. In the end, you are probably even inspired to pursue a college degree or career in this field. Nowadays, people with machine learning skills are sought after at the job market. In future, it could be even more like so. Most importantly, you are taking this course is not because someone else, like your parents, tell you so, but because you want to. In the classroom, students had a self-introduction to the rest of the class. Since the class is at the full capacity with 25 students, students' self-introduction is kept brief, each within a 1-minute limit. If you are watching this video online, you may try to answer the following questions by yourself. As to myself, the instructor, my name is Kevin Ho. I have a mixed background academically and professionally. I have a master's degree in computer science and MBA with a concentration in finance. My work in the past 16 years in the US financial industry has been at the intersection of financial engineering, modeling, and analysis. In recent years, financial industry, as you know, is increasingly embracing machine learning as the approach for all kinds of analysis. As a result, applying machine learning to predict and forecast has been the main responsibility of my jobs in recent years. So now the question, what is artificial intelligence? What is machine learning? What's the connection between the two? Man-made machines or robots can do things that an intelligent body like humans do, or probably even better than humans can. This is one definition of artificial intelligence. Such a machine or robot has been dreamed of by researchers for decades or centuries. You see this a lot in science fictions. Machine learning is a branch of artificial intelligence, and nowadays it is de facto the predominant and most effective approach for developing artificial intelligence. Machine learning is the science of getting computers, machines, to act without being explicitly programmed. In the early days, one approach to developing artificial intelligence was to instruct or program machines explicitly what to do. Over time, it is realized that explicitly programming machines for what to do under all different situations could be a mission impossible. Just imagine when a person drives a car. It is impossible to have an instruction book telling the driver, the person, exactly how to control the wheel, acceleration pedal, or brake in all different conditions or combinations of conditions such as weather, light, signs, traffic, road, time of the day. So one effective way to develop artificial intelligence is let the machine continuously learn and continuously improve itself through feeding more information, recognizing patterns between information, and becoming more and more intelligent over time. One way to look at this is artificial intelligence is about what, and machine learning is how. Fully autonomous self-driving car is one application of where a man-made machine is capable of doing things that humans can do. By now, the self-driving capability backed by machine learning approach is almost there. Tesla and Google are leaders in the area. The video we're playing now is a demo of Tesla's self-driving car's capability. Tesla's self-driving car is very neat, right? Before we go into questions today, let me tell you the assignments before our next class. The first assignment is for you to find interesting stuff online about machine learning and artificial intelligence. Below, I also provide you a few links for your reference. The second assignment is to install Anaconda and Python package to your computer. I will send you the instructions after the class. So now, questions. What questions do you have about this course in general or today's welcome section in particular?